So, okay, this is the series that we'll be doing today. It is 1, 4, 9, 16, 25. And this we have to generate up to the 10 term. So clearly it says that we have to generate 10 terms, okay? Because it says up to the 10 term and the series is like this. So in order to solve any series program, first of all, we should know how the series is being formed. Now, after 25, what is the next number that comes? If we can figure out that particular number correctly, then we know that we have understood this series and we can write programs generating that particular series. So first, let's try to understand that particular series. Okay, so here I'll just write down. Okay, let me make it full screen. Okay, so the series is like this: 1, 4, then is 9, then it is 16, then is 25. So what is the next number? So if you look at this series closely, then this series is the square of the numbers, that is 1, 2, 3, 4, 5. So when we square all these numbers, that is 1 square we get 1, 2 square we get 4, 3 square we get 9, 4 square we get 16, and 5 square we get 25. So definitely the next number that will follow after 25 is going to be the square of 6, which is 36. Okay, it is 36. Next number is going to be 7 square, and that is 49. So this series has to continue up to the 10 term. So 10 term means it has to be the square of 10, and that is going to be 100. So it is 1 square, 2 square, 3 square up to the 10 term. So what exactly we need to generate this series is the numbers, and the numbers are 1, 2, 3, 4, 5. If we can generate 1, 2, 3, 4, 5 up to the 10 term, then while printing, what we'll simply do is we'll square those numbers. So if we can generate 1, 2, 3, 4, 5 up to the 10 term, in order to get our required output, we simply square those numbers. Then we get our required output, which is 1 square, 2 square, 3 square, 4 square, 5 square, and so on. So let's see how we can do this in our program. And as discussed before, all these programs will be done using sub procedure, because series programs will be doing only, you will be using only sub procedure. So let's declare, that is declare sub series. So series is the name of the sub procedure. Then CLS. Now there is no input. We don't need any input for series program. So we directly call the sub procedure, which is series. And after this, we write down end. So this is basically our main module. Now let's go towards the definition part. And definition part starts with sub. Sub series. And here we write down the definition. Okay. Now what we want to generate is, we want to generate this 1, 4, 9, 16. So everything has to be done up to the 10 terms. So let's form a loop which will run 10 times. 1 to 10. Okay, our loop is ready. Now what we need to do is, we need to display the square of all these numbers. Square of 1, square of 2, square of 3, square of 4. That's what we have to display. And 1, 2, 3, 4, 5, 6 up to 10 will be in this variable I, which is also the loop variable. So loop variable I holds 1, 2, 3, 4 up to the 10 term. So what we'll do is, we can use this variable and we can get our required output, and it is done like this. So if we simply do like this, suppose if I simply print I, then the output will be this one: 1, 2, 3, 4, 5, 6, 7, 9, 10, which is not the required output. Okay, which is not our required output. Our required output is, we have to square all these numbers. Square, we have to square 1, we have to square 2, 3, 4, 5. We have already displayed, we have already displayed 1, 2, 3, 4, 5. So only thing left to do is to square these numbers. Then we get our required output, and it is done over here. Now this is the part where we display. So here, this is right now 1. I holds 1. So 1 square. Then I becomes 2. Then we have to display 2 square. So we have to square this, and to square we use exponentiation. Then we write 2. So this is 1 square. Then Next time I becomes 2. This is, then it is 2 square. Then I becomes 3. This is 3 square. Then 4 square, 5 square, and so on. Okay, let's run our program. Okay, because of semicolon, everything is coming in the same line, and this is what we want. 1 square, 2 square, 3 square, 4 square, 5, 6, 7 square, 8 square, 9 square, and so on. Okay, now this is the program. Now after this, we will move towards another set of programs, and it is this one. It is 2, then it is 3, then it is not 4, but it is 5. Then we have 8. Then we have 12, and so on, up to the 10th term. And if you have any difficulty, then do write in the chat section, okay? Because I frequently check the chat section if there is any message or not. So far, I haven't received any messages. So yes, we are good to go. Okay, now this is the series, and we have to display this series up to the 10th term. Now, first of all, as that of before, we have to understand this particular series. So it is like this: 2, then we have 3, then it is, what is this after? Yeah, it is 5, then we have 8, then we have 12, and so on. So what is the next digit? So if you can figure out this particular digit, then yes, we know, we can say that we have understood this series and we are ready to write the program. So okay, if you look at this series carefully, there is 2 at the beginning. The first number is 2, then we have 3. So with the help of this difference, we can form this particular series. So the difference right now is 1. Now here the difference is 2. After 3 we have 5, so the difference is 2. Then after 5 we have 8, so the difference is 3. Here the difference is 4. So the next number, for next number, the difference is going to be 5. So 12 plus 5 is going to be 17, and that's the next number. Now for next number, there is going to be the difference of 6, and the addition of 17 and 6 will give us our next number. So this is how this series is being formed. So if you look at this difference over here, the difference is 1, then it is 2, then it is 3, then it is 4, then it's 5, then it's 6. And our number, it goes like this. So what we'll do over here is we'll be using 2 variables. The first one we will be using to display all these numbers. To display all these numbers, we'll be using one variable. And for the difference, we will be using another variable. And for difference, we will be using D. Whereas for to display these numbers, we will be using variable P. Okay, so let's see how this is done. The difference is there. The difference increases by 1. The difference starts with 1, and it always increases by 1. And the first number that we have to display is P. Display is 2, and that will store in variable P. And what we'll do is, to generate our next number, what we have to do is we have to add P and D, because P at the beginning will be 2. We'll assume we will store 2 in variable P. So 2 is the first number, and to get our next number, we have to add 1, and that one will be stored in D. So P plus D will give us 3, and that number will store in P, because P is a variable which we will be using to display our number series. So P will be 3. Next time, D will increase. D equal to D plus, we have to increase D. So, and we have to increase D by 1. So we will increase D by 1 like this. D equals to D plus 1. So that D was 1, 1 plus 1 is 2. And then again, now next time, this 3 is going to be P, and it will be added with 2. Then we get 5. Now, at this moment, if it is confusing to you, then no problem. What we'll do is, first of all, we'll write the program and we'll trace the program. And when we trace the program, you will clearly understand what I'm trying to refer with all this. Okay, P equal to P plus D and D equal to D plus 1. So far, what you understand is, we need 2 variables. The first variable P, we'll be using it to display the numbers, and we'll be using variable D to get the difference. And difference always increases by 1, and it is 1, 2, 3, 4, 5, 6, which is the increment of 1. Okay, so let's go to our editor and let's may solve this particular program. Okay, now let's go towards the definition part, which is sub series. Okay. Okay, sub series. So here is our definition part. Now inside this definition part, the first thing that we have to do is we have to uh, store two numbers at the beginning. One is 2 and another one is 1. This is for the difference and this is for the printing part or the to display. So P is going to be 2 and for difference I'm using variable D and D has to be 1 at the beginning. Okay, now let's form a loop. Since we have to display 10 numbers, let's form a loop which will run 10 times. So 1 to 10, it will run 10 times. You can even write 10 to 1, step minus 1, no problem. But try to be as simple as possible, and 10 to 1 compared with 10 to 1, 1 to 10 is much more simpler, okay? Because step and all those things are not necessary over here. Now, the first thing that we have to display is we have to display value 2. So 2 is already ready in P, so let's print it, P. Okay. Now, next time, the value of P has to become 3. To become the value of P3, we have to add 1 in it. So 1 is ready in D. So let's add it. So P is equals to P plus D. So this is what I was trying to refer. Okay, P equals to P plus D. So that what happens is our control will go up and it will print the value of P. Now P right now is 2, so 2 is printed. D is 1, 2 plus 1 is 3. So the new value of P is 3. So it will go up and it will print 3. Now it's not yet over because our difference also is increasing by 1. It is continuously increasing by 1. D is 1, then it becomes 2, then 3, then 4, then 5, then 6. So it is continuously increasing by 1. That's why we have to increase the value of D also by 1. And this is the statement which we'll be using to increase the value of D. So let's write it down. So let's increase the value of D, which is D is equals to D plus 1. So we have done everything. We have displayed P, we have increased the value of P by adding the difference, and even we have increased the difference by 1. So this is all we need to do. Let's see the output, and this is what we got. So at the beginning, there is a difference of 1, then 2, then 3, then 4, then 5, 6, 7, 8, and 9. And altogether, it is of 10 terms. So this is our program. Now let's trace this program and let's try to see how the output is being generated. Okay, here and here. So at the beginning, what we have is we have P is equals to 2, then we have D is equals to 1, and we have I, which is a loop variable. Okay. So P at the beginning is 2, D1, I also 1. Now this value 1 is valid in this range. So our loop becomes true and it will go towards its body part, which is this one. So at the beginning of the body, we have print P. So value of P will be printed, which is 2. Everything will come in the same line. Then P equals to P plus D. P is 2, D is 1, 2 plus 1 is 3. So the new value of P is 3. D equal to D plus 1. So D will increase, D becomes 2. Next will take us to step, no step, I will increase, I becomes 2. 2 is also valid in this range, so it will go down, print P. So we have 3 over here. So 3 will be displayed. Now here, P will add with D, which is 3 plus 2. 3 plus 2 is 5. And the new value of P is 5. D equal to D plus 1. It will again increase, it becomes 3. Next, it will go to step, no step, I will increase, I becomes 4. Print P. P means it will display new value, which is 5. So again, addition will take place, P plus D. 5 plus 2 is I missed out, I guess. I missed out this part. D plus 1, 3. This part I missed out. Next. Okay, 5 has already printed. Okay, now 5 plus 3. 5 plus 3 is going to be 8. So this is going to be 8. And D will increase. D will increase by 1, so D is going to be 4. So if there is any problem, then do let me know, okay? Because there was something went wrong while I traced this one. So if you want me to trace from the beginning, then yeah, do write me in the chat section. We can do everything from the beginning. But if you are following, then no problem, okay? So we have 4 over here. Next will take us to step. No step. I will increase. I becomes 5. Then I is also valid in this range. Print P. Now P means it will display a new value, which is 8. So again, addition will take place. 8 plus 4 is 12, and 12 will be stored in this variable P. D will also increase. D becomes 5, and so on. And this is going to continue, and it will display the it will display this particular series, that is up to the 10 terms. So we have 12. So 12 will be displayed. Then 12 will be added with 5, which is 17. Then 17 will be displayed. It will be 6. 17 plus 6 is 23, and so on. Okay, now after this program, we'll move into another set of program, which is this one. 1, 1, 1, 1, 3, 4, 1, 2, 3, 4, 5. Okay, this is the series that we have to generate. It is for 1, then 2, 1, then 3, 1, 4, 1, and 5, 1. Okay. Okay, our main module is almost the same. That is declare, sub is there. We have already called this series. The only change that will take place is in the definition part. So let's go to the definition part. And here at the beginning, we have 1. So let's keep 1. Okay, one more thing I forgot to show you is this one. Here we've been using variable D. Okay, now just pay attention for a while that we are using variable D for the difference. And if you look at this difference carefully, then the difference is 1. The value that is that we need for the difference is 1, 2, 3, 4, 5. And if we look at this loop variable I, it also gets value 1, 2, 3, 4, 5. Okay, so in this case, whatever values we need for D are satisfied with I as well, because I, it starts from 1 and it will go till 10, and the values that will be stored in I are 1, 2, 3, 4, 5 up to the 10, and that's what we are generating in D. So instead of using variable D, we can even use variable I. And to use variable I, what we have to do is, here we have to add 1, then we have to add 2, then 3, then 4, then 5, then 6, and accordingly we increase the difference. But this 1, 2, 3, 4, 5 is ready-madely ready in I, so we can simply write I as well. And if we run this, then we get the same output. So this is also the way you can do, okay? Because whatever difference value we need, that value is already in I. So instead of using extra variable, we can simply use the variable that we have in our program as well. But if we don't have this kind of thing, okay, then if we don't, then in that case only we use other variables. Like suppose if our difference was from 3, then if it is 5, then it is 7, like that, then we don't have those values in any variables. In that case we use different variables. But since here in our program I can satisfy all the values that we were generating in D, hence we are using variable I over here. We can do like this also. Or if you find previous method easy, then you can stick to that as well, no problem. Okay, so being said all that, let's move towards our new program, which is this. So let's first of all see how this series is being generated. Okay, let me use this editor. Okay, what we have is we have 1, then we have 2, 1, then we have 3, 1, then we have 4, 1, and finally 5, 1. 1, 2, 3, 4, 5. Okay, so here what we'll do is at the beginning we'll take a variable and we'll store the first value, which is 1. Now to generate the next value, which is 11, what we'll do is we'll multiply this 1 with 10 and we'll add 1. So this is how our next value will be generated. That is 1 into 10 is 10, 10 plus 1 is 11. So we get 11. Now for the next number, what we'll do is we will multiply 11, that is our previous number, this previous number, with 10, multiply with 10 and add 1. 11 tens is 110 plus 1, we get 111. Now for this number, what we'll do is, okay, for this number, we'll multiply previous number with 10 and add 1. That is 1, 2, 3, not 1, 2, 3, 1, 1, 1 into 10 plus 1. So if we solve, we get 4 ones, which is 4 ones. Now for this particular number, multiply our previous number, which is 4 ones, with 10 and add 1. Then we get 5 ones. So this is basically how we solve this particular series. So if you look at this particular method over here, this is always same, okay? We are always multiplying with 10 and we are adding 1. Always multiply with 10 and add 1. And which number to multiply and to add? The previous number. So what we'll do is, first of all, we'll store 1 in variable p. Then we'll make p 11 by this method, okay? And then we will multiply again p with 10 and we'll add 1. And this will keep on going up to the 5 terms, okay? Then we get this particular series. So let's see in our program and let's see how we can solve this. Okay, let's go to the definition part. Here we have our definition part. At the beginning, we have 1. So we need a loop which will run 5 times because there are 5 numbers to be displayed. So 1 to 5. So at the beginning, we have to display 1. So 1 is already ready in P. So print P, 1 is printed. Now here what we have to do is, we have to multiply 1, which is in P. We have to multiply with 10 and add 1. Not I, but add 1. So this is what we have to do. So run this program. Yes, we get the output. And everything will come in a straight line or same line because of this semicolon right here. So, okay, let's trace our program and let's see how this output is being formed. Okay, at the beginning, value of P is 1 and value of I is also 1. Okay, so print P means it will display the value of P, which is 1. Then here, this line, P is equals to P into 10 plus 1. So P is 1. 1 into 10 is 10, 10 plus 1 is 11. So 11 will be stored in P. So the next value of P is 11. Next will take us to step, no step, I will increase, I becomes 2. 2 is also valid in this range. It will go down, print P, means new value, 11 will be displayed. Okay, this line, P is 11, 11 into 10 is 110, 110 plus 1 is 111. So P holds value 111. Next will take us to step. I will increase, I becomes 3. 3 is also valid in this range. So it will go down, print P, it will display 111. Okay. Now it will come here over here in this line. So P is now 111. 111 into 10 is 1110 plus 1 is 1111. So the new value is 1111. Next will take us to step. There is no step. I will increase. I becomes 4. 4 is also valid in this range because our loop variable, it is valid from 1 to 5, where 4 also lies. So it will go towards its body part. It finds this first line, which is print P. P is 1111. It will be displayed. Then we come to this line and this will add one more 1 over here. It becomes 11,111. So next will take us to step, no step. I will increase further by 1, which makes it 5. 5 is also valid in this range, print P. So we have 1, 2, 3, 4, 5. Okay. We have 5 ones. Then, okay, after printing 5 ones, it will come to this line. Now this will again increase one more P. One more 1 over here. Next will take us to step, no step. I will increase by 1. It becomes 6, and 6 is invalid. Now 6 is invalid in this range. Our loop will terminate and our control will come below next. Below next is end sub. It will terminate our sub procedure. Then it will go towards our main module. It will come below call. It will come to end and our program will terminate and we get this as an output. So this is how we get 1 1 1 3 1. Now suppose if question comes with 2 2 2 2 or 5 5 5 3 5 4 5, then the only change that we have to make over here is in this variable p. So if it is 5, then 5 5, then 3 5, then 4 5, then 5 5, then just edit over here, write 5, then you get the correct output. Is this correct output? No. Why? Because we are adding 1 over here. Instead of 1, what we have to do is we have to add 5. Then we get the correct output. Now if it is 2 or if it is any other number, just make it 2, and while adding, add 2. Then you get the required output. Okay. So now let's move towards another program, which is kind of a reverse of this particular series, which is 1 2 3 4 5, then we have 4, then we have 3, then we have 2, then we have 1. Okay, the reverse of the previous one. Now for reverse, what we'll do is, for reverse, what we'll do is, it is 1 2 3 4 5, then 1 2 3 4, 1 2 3, 1 2 and 1. So for reverse, what we have to do is, from at the beginning we'll store the first value, which is 5 ones. Then what we'll do to get the next number, what we'll do is we'll divide this number. We'll divide this number by 10. Now this division sign, okay, be very much careful with this. This is a integer division. Now whenever we divide this number by 10, what we get is we get 1234.1. Okay, this is what we get in our quotient part. Now what we want is, we just want the integer value 1 2 3 4, and this 4 ones is in the integer part. This decimal part is not required. So to ignore that part, what we are using is, we are using integer division. P is equal to p slash, it is p is equals to p slash 10. This is a integer division. So because of this division, this decimal part will be ignored, and whatever is our next number, that is exactly what we get after we divide. Now for this particular number, what we'll do is, we'll divide this number, previous number, by 10 exactly with integer division. Then we get 31.1, and 0.1 will be ignored, and remaining will be 31. Then it is 2 1, then it is just 1. So let's see how this is done. So basically this is the logic that we'll apply to solve this particular program. So let's see in our editor itself. Okay, now let's go to the definition part, and the first number that we have to print is 1 2 3 4 5. Now here also, yes, we have to display up to 5 terms, so our loop has to run 5 times, which is 1 to 5. Now first number is 5 ones, which is already ready in P, so we have already displayed it. Now for the next number, what we'll do is, we will divide by 10, and this is the symbol. Okay, P slash 10. Now P slash 10, what it will do is, it will remove the last digit, that is 1 will be removed, and 4 1 will be stored in P, and it will go up and it will print, and we get this as an output. It's as simple as that. Okay, so let's trace this program as well and see how the output is appearing. Okay, the value of P is 5 ones at the beginning. I is 1. Okay, I is 1, which is valid. Then print P. Print P means 1 2 3 4 5. Then this particular line, what it will do is, it will divide the value of P by 10, and it will ignore the decimal part and only give the integer part. So when we divide, we get 1 2 3 4 5.1. Here 0.1 will be ignored, and remaining is 1 2 3 4, and that 4 ones will be stored in variable P over here. Okay, next will take us to a step. I will become 2. 2 is also valid. Print P. So 4 1 2 3 4 4 ones is displayed. P equals P slash 10. Again, 1 will be removed. 111.1. 0.1 is removed. 111 is left. Okay, next will take us to step 3. 3 is also valid. Print P. It is 1 2 3. Then again, this line will remove 1, 1. It will become 11.1. Point 1 will be removed. 11 will be stored in P. Next will take us to step. No step. I will increase. It becomes 4. 4 is also valid. Print P. That is 11. Again, division will take place and the result is 1.1. Because of integer division, 0.1 is ignored. Only 1 will be left in P. Next, no step, I will increase. I becomes 5, which is a valid number. Print P. So 1 will be displayed. P equal to P slash 10. So again, what will happen? Our result is 0.1, where 0.1 will be ignored. So P will be 0. Next will take us to step. I becomes 6, which is invalid. So it will come below next. And this is the output that we'll see in our screen. Okay.
Thank you so much for watching. Please do like my video so that I get motivated to create more of these videos. We would appreciate if you would share this video with your friends. And if you have any queries and suggestions, let me know through the comment section. Lastly, please do subscribe my channel and press the bell icon so that you get notified every time I post a new video. Thank you.